Okay, so welcome everyone. We're going to be looking at periodic functions today, and this will be our last video lesson on algebra before you guys come back next week, and we will start on calculus. So first thing to look at is the unit circle. Okay, so the unit circle is a circle whose center is on the origin and whose radius is 1. So any right angle triangle that hits the center and the circumference, the hypotenuse of that will be 1 because that's the radius. And using that, we can then calculate the value of sine and cosine of the angle really easily, because sine and cosine are the opposite and the adjacent over the hypotenuse, and because the hypotenuse is 1, opposite over hypotenuse equals the y divided by 1. Y divided by 1 is just y. Cos of theta, the adjacent over the hypotenuse, the adjacent is x. Therefore, x divided by 1 is just x. So sine theta equals y, and cos theta equals x. All right. So this point up here has a x value of cos theta and a y value of sine theta, p. All right, so the unit circle is really good for knowing a bunch of different values, and I'll show you that in a second. But for you guys to memorize, the only thing that we're really interested in is that at 0 degrees or 0 radians, x is 1, y is 0. So cos 0 is 1, sine 0 is 0. At 90 degrees or pi over 2, so if theta is 90 degrees or theta is pi over 2 radians, cos is 0, sine is 1. If theta is 180 degrees or pi radians, cos of theta is negative 1 and sine of theta is 0. And if theta is 270 degrees or 3 pi over 2 radians, cos of theta is 0, sine of theta is negative 1, and then we go back. So you get something like this. So as theta changes, both the sine wave, both the sine wave and the cos wave are moving as theta changes. And you notice that this is a repeating function. Both of these are repeating functions, and they will go on forever. So what we do is we have theta on the x-axis of our functions here, and for our top function here we have cos theta. Here we go, cos theta. Okay, so this is cos theta here, and we see, we'll wait till it gets to 0 again, and it's 0. When theta is 0, cos theta is 1, and we come down until we get back to again. Okay, and the same for sine. So we plot theta on the x-axis and plot sine theta or cos theta on the Cartesian plane. So you can think of a number of possibilities for these. We're going to be touching base on Friday about some real-life implications of periodic functions. But for now, we're going to be sticking with the theoretical. So these guys have a formula. Okay, so y equals mx plus c, y equals ax squared plus bx plus c, all of those. The sine formula has 4 variables, a, b, c, and d. A is the amplitude, so amplitude is the distance between the midpoint and the highest or lowest point, or you could just find the peak minus the trough and divide that by 2. Basically, it gives us how big the wave is, how high the wave is. The period is 2 pi divided by b. So as b increases, the period is going to shorten. As b decreases, the period is going to get bigger. And the period is how long the periodic function takes to repeat. This is an example of sine x, by the way. The horizontal shift is c. So when c increases, we shift our graph to the right. When c decreases, we shift our graph to the left. And the constant is always going to be a vertical shift, regardless of what formula we have. So plus d is obviously a vertical shift. As we increase d, it moves up. As we decrease d, it moves down. And I will actually show you this now. I've made this here for you guys, so please feel free to muck around with it. Cool. So I've got this same graph. Actually, it's the exact same graph here. And I can increase A or decrease A. If you notice, as A equals 0, it's just a straight line. As when A gets negative, it actually inverses. B, as B gets bigger, the period gets shorter. As B then gets less than 1, I'm going to try and not hit 0 here. Here we go. So you can see when B approaches 0, the period of the graph becomes longer, and then obviously when we get into negatives, it inverses. C is the horizontal shift, and D is the vertical shift. So this link's on eLearn, muck around with it. Okay, so for example, 2 sine 4x take 0.5 plus 3. Okay? So A is 2, so therefore the amplitude is 2. Therefore, our graph is going to go from the midpoint, and then from the midpoint, it's going to go 2 in each direction. So we have our midpoint here, and amplitude is going to be 2. The period is 2 pi over b. b is 4, so 2 pi divided by 4 is just pi divided by 2, pi over 2. Therefore, the period is going to be pi over 2. The period for a normal sine graph is 2 pi. So this graph is going to be 4 times. It's going to repeat 4 times for every 360 degrees, or 2 pi radians. The phase shift is 0.5, so we're going to be moving it 0.5 to the right. You can see here, this here should be here, because sine of 0 is 0. So it should be here. But we've shifted it 0.5. And we have a vertical shift of plus 3, so vertical shift up of 3. So the midline is 3. In fact, if you want, you could even call D the midline. Really. So our midline is 3, our amplitude is 2, therefore we are going from 5 to 1, 2 on each side. We have shifted 0.5 to the right, and we have a period of pi over 2. So about cosine, cosine is, if we go back up here, cosine is just pi over 2 behind sine. So if we look at them here and get to 0, you'll see that cosine is just a little bit ahead of sine. So cos x equals sine x plus pi over 2. Okay, but I'm not going to be asking you to compare between them until we get to derivatives anyway. But point being, these four do the same thing for cos as they do for sine. Okay, for the reading and writing task, I want you to look at this diagram. So this diagram has a bunch of different wavelengths of light. What property of the periodic functions that we've talked about in this lesson affect the color? Okay. Now, you guys have a worksheet booklet in eLearn, and it's 4 pages long. So this is going to be your work for the next couple of lessons, and we'll be touching base on these on Friday's live session. Oh, it's 3 pages. That's fine. So have a go at these, and this will be practicing your knowledge of what we've just gone over. If you are having any issues with these, please email me, and we'll have a chat.